Welcome to Chemazon-Complete Chemistry. So in today's video, we are going to solve a question based on chemical shift that was asked in JAM 2016 chemistry paper. So this is a structure that they've given, and what we have to do is we have to identify the order of chemical shift of these four labeled protons 1 to 4. So just by looking at this structure, the electronegativity, which is most electronegative atom, the oxygen. Okay, so the group, methyl group that is attached to oxygen, it will have the maximum value of chemical shift, or it will be most de-shielded. Okay, because it does not have any electron density around that, because of the oxygen that is withdrawing electron density via -I inductive effect. So this is most de-shielded, so it will experience maximum magnetic field, external magnetic field, so it will have maximum value of the chemical shift. So Me2 will be maximum, so we have to arrange in the increasing order. So which could be the correct answer? Here Me4 is maximum, A will be incorrect, Me1 maximum, incorrect, 2 and 2, so either B or C is the correct answer. Now after this Me2, if you see here, this Me1, it is closest to the ester group, the carbonyl group, so this will be second most de-shielded group of protons, that is Me1. Okay, so Me2 then Me1, so this is the correct answer. C will be incorrect. Now between 3 and 4, if you see 3 and 4, here 3 is what? It is attached to an sp3 hybridized carbon, okay, which has how many percent character? S character. It has 25% S character. Okay, and this one, if you see, it is attached to an sp2 hybridized carbon, which has 33% S character. Okay, and we had seen the electronegativity is directly proportional to what? Percentage S character. So the next de-shielded proton will be 4 and the least will be 3. Me4 and the least would be Me3. Now, so what is the correct answer for this question? The correct answer will be option B. Now, if you want to confirm using the chemical shift values, again you can see here alcohol, ether and also ester. Okay, the carbon group of proton attached directly to oxygen, the value is 3.3 to 4.5. Then comes the aromatic methyl group, that is 2.4 to 2.7, and then comes the vinylic. Okay, as we told that this is attached to an sp2 hybridized carbon, it is 1.6 to 2.2, and the least would be this primary, which is 0.7 to 1.3. Okay, so from the table also you can confirm the answer. Now there is one more question that was asked in JAM 2013, as we had discussed in the last video of chemical shift. The number of peaks or signals in 1H NMR of N N-dimethylformamide. Okay, now here the thing is that they have not given the structure. Okay, this is a numerical answer type question or NAT. So just we have to write down the number, okay, how many peaks will be seen. So for that we must know the structure of this compound, N N-dimethylformamide. Now what would be the structure? Now what is formamide? Form means one carbon. Okay, so one carbon amide, what would be the structure? H, C double bond O and NH2. CONH2 is amide. So this is the structure of formamide. Now we want N N-dimethyl. So both the nitrogens are what? They are substituted by methyl groups. CH3, CH3, C double bond OH. Okay, now suppose you count. Okay, suppose this is one signal because it is attached to sp2 hybridized carbon, and both these are attached to nitrogen. Right, so suppose this would be the second signal, and if you write the answer as 2, that would be incorrect. Okay, now let us see why that would be incorrect. Because like in alkene there is bond rigidity, similarly Similarly, here also what will happen, this nitrogen is involved in resonance with the carbonyl group. So if I draw the another resonance structure, it would look like this: O minus, oxygen having 3 lone pair, then double bond, then nitrogen, then CH3 and CH3. Now if you see the chemical, now if you see the environment, this hydrogen, so if you see the chemical environment here, the hydrogen, it is attached to this carbon, so this is in a different chemical environment, this will give one signal. Okay, if you see this methyl group, if you see this methyl group, it is cis 2 oxygen, but it is trans to the other hydrogen. And if you see the other methyl group, if you see this methyl group is cis to the hydrogen and it will be trans to the oxygen. So both these methyl groups are present in different chemical environment. Okay, so both the methyl groups will give different signals, 2 and 3. So what would be the correct answer? The correct answer would be 3 signals. Okay, I hope you have understood both the questions, the one on chemical shift and this one, N N-dimethylformamide. Thank you.